All right, let's look at the second part on how to find turning points. Now, in this case, rather than choose a parabola, I've chosen a cubic. And the reason I've chosen a cubic is this is going to have more than one turning point. This is going to have, well, being a cubic, it's going to have two turning points. A cubic, of course, is going to look something like, and I'm just going to guesstimate this, it's going to be something like that. Yeah, it's going to be a turning point here, there's going to be a turning point somewhere over here, and that's how it's going to look. But because it's got two turning points, we've got an extra step to make here, and let's have a look at how that plays out. So very, very simple. We have our equation, so I'm going to rewrite the function. I'll write it over here so I've got a bit more space. So y is equal to x cubed on 3 plus x squared on 2. I actually like that, but just in case you're a bit confused by that, that's really the same as saying y equals 1/3 x cubed plus 1/2 x squared. So now we're going to differentiate it, because the moment we find the gradient function, we just make the gradient function equal to 0, because the one thing we know about the point over here, the gradient there is 0, and the gradient wherever that is there is also going to be 0. So let's do that now. So let's differentiate y with respect to x. So 3 times 1/3 is 1, so it's going to be 1x. We're going to reduce the power by 1, it's going to be 2, plus 2 times 1/2, well, 2 times 1/2 is 1, x, and it's going to be the power of 1. So I'm going to rewrite that because I don't really like that. So the m value, I'll just put m here. M is equal to, and by the way, there's going to be multiple m values here. It's going to be x squared plus x. Now, we need to be able to find the value of x. So in order to do that, I'm just going to factorize. Now, the moment I factorize, it becomes a very familiar type situation. So this is equal to, and in fact, I'm going to make m equal to 0 straight away. This is equal to, and it's going to be x times x plus 1. So now we can work out what x would be. So either x is going to equal 0, or x plus 1 is 0. So I'm going to write that out. Either x is 0, or x plus 1 is 0. Just in the same way we do for any quadratic. And of course, if x plus 1 equals 0, x must equal -1. So I've got a value for x and another value for x. So far we've got turning points where x equals 0 and x equals -1. Now we just need to pop those back into the original equation to find out the values for y. So let's go ahead and do that. I'll just make a little sidebar here. So here's my original equation. Y is equal to x cubed over 3 plus x squared over 2. And I'm going to take the values from here, 0 and -1, and put those there into this equation here. So I'm going to start, I'll do the 0 first. So if x equals 0, we could say y is equal to 0. Because if I got 0 cubed on 3 plus 0 squared on 2, well, that all comes to 0, because 0 plus 0 is 0, so therefore y is 0. We can also say if x equals -1, y equals, and now I'm going to actually have to substitute it in, yeah? So I'm going to say this is going to be -1 cubed on 3 plus -1, oops, you can't see that, -1 squared on 2. Well, -1 cubed is going to be -1. So this is going to be -1/3 plus, well, a half. Well, a half squared, sorry, -1 squared is 1. So it's going to be 1/2. So really it's -1/3 plus a half. Now, if you're not sure how to do that, you could just simply go back to the calculator here. Let's have a go at doing that. So it's going to be, what is it? A half minus a third. So you can just go here, 1/2 minus 1/3, and there, oh gosh, that's a weird one. 1/2 minus 1/3, oops, not having much luck today, equals 1/6. So y equals 1/6. So now you've got your two coordinates. So you can put therefore turning points occur at, I'll use an at symbol. The first one is 0, 0, and what else we got? -1, 1/6 for the equation. I'll put EQN, and I'll rewrite it out. Y is equal to x cubed on 3 plus x squared on 2. And you really want to finish with a summation of what you've just found. But that's how I would go about finding the turning points for this this function here. Now I'm going to get you to have a shot at doing some of these. Now I'm going to include here, this is, what is it? It's page 314 from the Theta textbook, and exercise 21.05. And now I'll just quickly show you this, just in case you're wondering. Here it is, 21.05. It says, determine the coordinates of each turning point of the curves. State whether each point is a maximum or a minimum. Don't want you to do that bit. Yeah. So all you're going to do is find the turning points. There's a whole bunch of them to do. You'll notice some of them are squares, some of them are cubes, and you're just going to follow exactly what we just did there. And look, here's one. Here's one because it's got a third x cubed. So very typical, excuse me, should be very familiar, exactly what to do there. Give it a good go. Any questions, do get back to me. Delighted to help. And in a moment, for the next part, I'm going to show you how to find whether what the result is a maximum or a minimum.